Fluid mechanics is the branch of physics concerned with the mechanics of fluids and the forces acting upon them. It can be divided into fluid statics, that is the study of fluid at rest, and fluid dynamics, the study of effect of forces on fluid motion. Altogether, they are called as fluid mechanics. So in this section, we will deal with certain important questions pertaining to fluid mechanics. As such, what is boundary layer? What is the difference between path line and streamline? What is a Newtonian fluid? What are the differences between elbows and bend? What is the function of a butterfly valve, and many more. Explain the difference between rotational and irrotational flow. Rotational flow is when the particles of fluids are all rotating about their own axis, in addition to their other movement. Irrotational flow is when the individual particles are not rotating around their axis. The answer to this question would be, in rotational flow, the vorticity is non-zero, and in irrotational flow it is zero. In irrotational flow, the net rotation of a fluid element about its own mass center is zero as it moves from one place to another. What is boundary layer? In physics and fluid mechanics, a boundary layer is the layer of fluid in the immediate vicinity of a bounding surface where the effects of viscosity are significant. The answer to this question would be, boundary layer is the fluid layer in the neighborhood of a solid boundary where the effect of fluid friction are predominant. What is the difference between path line and streamline? Streamlines are a family of curves that are instantaneously tangent to the velocity vector of the flow. This shows the direction in which a massless fluid element will travel at any point in time, whereas path lines are the trajectories that individual fluid particles flow. The answer to this question would be, a path line is a curve traced by a single fluid particle during its motion. A streamline, on the other hand, is an imaginary line drawn in a flow field, such that a tangent drawn at any point on this line represents the direction of the velocity vector. There is no flow across the streamline. Navier-Stokes equation represents the conservation of which quantity? Navier-Stokes equation in fluid mechanics is a partial differential equation that describes the flow of incompressible fluids. The answer to this question is, the quantity that the Navier-Stokes equation represents is the momentum. What is viscosity? What is Newton's law of viscosity? Viscosity is the physical property that characterizes the flow resistance of simple fluids. Newton's law of viscosity defines the relationship between the shear stress and shear rate of a fluid subjected to a mechanical stress. The answer to this question would be: viscosity is the property of the fluid which measures the resistance of the fluid to the gradual deformation due to the shear stress. And Newton's law of viscosity states that the shear stress on the fluid is proportional to the velocity gradient. What is meant by no-slip condition in fluids? The no-slip boundary condition or no velocity offset boundary condition assumes that the speed of the fluid layer in direct contact with the boundary is identical to the velocity of this boundary. There is no relative movement between the boundary and this particular fluid layer. Therefore, there will be no slip occurrence. The answer to this question would be: no slip conditions occurs at the microscopic level where the fluid is flowing on a solid surface and the velocity of the fluid is 0 at the contact surface. What are the major and minor head losses in a fluid flow system? The major head loss would be like head loss or pressure loss due to friction in pipes and ducts. Minor head losses can be the pressure loss or head loss due to components as such valves, bands, teeth, and the like in the pipe or the duct system. The answer to this question would be: major loss is known as the losses that occur in the pipes. Minor losses are head losses which occur due to bends and elbows, that is, the additional part of the straight pipe system. Name some of the flow meters. Flow measurement is the quantification of bulk fluid movement. Flow can be measured in a variety of ways. A flow meter is a device which is used to measure the volume or mass of a gas or liquid. The answer to this question would be: some of the flow meters are orifice meter, venturi meter, rotameter, and nozzle. What is Reynolds number? The Reynolds number is the ratio of inertia forces to viscous forces. The Reynolds number is a dimensionless number used to categorize the fluid system, in which the effect of viscosity is important in controlling the velocities or the flow pattern of a fluid. The answer to this question would be: Reynolds number is the ratio of viscous force to the inertia force. Reynolds number, which is denoted by R suffix E, is given by rho V d by mu, where rho is the density, V is the velocity, d is the diameter, and mu is the dynamic viscosity. What is a Newtonian fluid? A Newtonian fluid is a fluid in which the viscous stresses arising from its flow at every point are linearly correlated to the local strain rate, that is, the rate of change of its deformation over time. So basically, we can say a Newtonian fluid follows Newton's law of viscosity, whereas a non-Newtonian fluid is quite spectacular. It doesn't follow Newton's law of viscosity, and as you can see, it behaves quite strangely. If a pressure is applied constantly, it will behave like a solid, but as soon as the pressure is removed, it will again act like a liquid. So the answer to this question would be, a Newtonian fluid possesses a linear stress-strain relationship and it passes through the origin. The fluid properties of a Newtonian fluid do not change when any force acts upon it. Newtonian fluids are the simplest mathematical models of fluids that account for viscosity. How does cavitation cause damage? Cavitation causes pump performance to deteriorate. There will be mechanical damages, noise and vibration, which can ultimately lead to the failure of the pump. Vibration is a common symptom of cavitation and many times the first sign of an issue. Vibration causes problems for many pump components including the shaft, bearings and seals. The answer to this question would be, in a closed system like that of a pipeline or pump, water evaporates rapidly in regions where the pressure drops below the vapor pressure. This phenomenon is called cavitation. The vapor bubbles formed in cavitation usually collapse in a very violent manner, which may cause excessive vibration, which can make rotating parts such as an impeller to contact non-rotating parts such as the wear plates or wear rings. Explain the difference between friction drag and pressure drag. Frictional drag is important for attached flows, that is, there is no separation, and it is related to the surface area exposed to the flow. Pressure drag is important for separated flows and it is related to the cross-sectional area of the body. The answer to this question would be, friction drag is the drag force exerted by a fluid on the surface due to friction action when the flow occurs past a flat surface at zero incidence. Pressure drag is the additional drag force on account of the differences of pressure over the body surface. The pressure drag depends upon separation of boundary layer and the size. How much hydrostatic pressure acts on a curved surface? The horizontal component of the total hydrostatic pressure force on any surface is always equal to the total pressure on the vertical projection of the surface and can be located through the center of pressure of this projection. The vertical component of the total hydrostatic pressure force on any surface is always equal to the weight of the entire water column, which is above the surface, extending vertically to the free surface, and it can be located through the centroid of this column. What are the differences between elbows and band, and which has greater head losses? All elbows are bands, but all bands are not elbows. Band has a larger radius than elbows, and generally the most basic difference is the radius of curvature. Elbows generally have a radius of curvature between 1 to twice the diameter of the pipe? The answer to this question would be band and elbow are used for changing the direction of the flow and is attached with the piping system. Bands are simply bands. They are generally custom made. On the other hand, elbows are well defined, engineered bands. Elbows can have angle 45 degree or 90 degrees, or they can be custom made. Using elbows or bands will cause some head losses, which is known as minor head loss. If the flow is turbulent in the pipelines, then elbows will have greater head losses than bands. In bands, it takes lesser time for the fluid to take the turns. So for designing a pipeline, these parameters are always kept in mind: where to put the elbow and where to put the bands. What is the function of orifice meter? Orifice meter is a device used for measuring the rate of flow of a fluid flowing through a pipe. It is a cheaper device as compared to Venturi meter. This also works on the same principle as that of a Venturi meter. It consists of a flat circular plate which has a circular hole concentric with the pipe. The answer to this question would be the orifice meter or orifice plate is used for measuring flow rate of a fluid. It is also used for flow restriction and pressure reducing purpose. What is a nozzle? A nozzle is a device designed to control the direction or characteristics of a fluid flow, as it exists an enclosed chamber or pipe. A nozzle is often a pipe or tube of varying cross-sectional area, and it can be used to direct or modify the flow of a fluid. The answer to this question would be nozzle is a device which can control the direction of the fluid, along with changing some of its properties. Nozzle is especially used for increasing the velocity of the fluid stream. Generally, these nozzles are a tapered tube. They are used where high velocity and low pressure is required, and it depends upon the continuity equation. What is priming of a centrifugal pump? Priming simply means preparing or getting something ready for operation. For a centrifugal pump to work properly, you need to fill it up with water. And this is what priming of a centrifugal pump is. The answer to this question would be when the impeller rotates, it adds kinetic energy to the adjacent fluid. As a result, the pressure of the adjacent fluid increases. At the same time, negative pressure is developed at the suction side. Because of this pressure differential, fluid flows through the impeller. If the impeller is filled with air rather than water, then the pressure differential will be small and no fluid will flow. So to eliminate this particular phenomenon, the pump flow path is filled with water, and this process is known as priming. What is the ratio of the thickness of thermal boundary layer to the thickness of hydrodynamic boundary layer? The thermal boundary layer thickness is the distance across a boundary layer from the wall to a point where the flow temperature has essentially reached the free stream temperature. This distance is defined normal to the wall in the direction. The boundary area up to which the local flow velocity has reached 99% of the velocity of the free stream is what a velocity boundary layer or a hydrodynamic boundary layer. The answer to this question lies in this particular formula. This is the ratio of the thickness of TBL, that is the thermal boundary layer, to the thickness of hydrodynamic boundary layer or HBL. What happens if centrifugal pump is operated at excessive speeds? When a pump is operated at excessive speeds, the differential pressure developed increases and causes a powerful pulsating vacuum on the underside of the blade tips, and each particle of water is pulled away from the blade, taking away with it a small particle of metal, producing a grooved effect. Repeated erosive action results in complete honeycombing and total destruction of blade, which eventually results in loss in the performance of the pump. What is the function of a butterfly valve? A butterfly valve is a quarter-turn rotational motion valve that is used to stop, regulate, and start flow. Butterfly valves are easy and fast to open. A 90-degree rotation of the handle provides a complete closure or opening of the valve. The answer to this question would be: in a butterfly valve, there is a disc which is hinged to the body. When an operator moves the butterfly valve, this disc also rotates and creates a blocked passage for the fluid to flow. When the disc is parallel to the flow, the liquid passes, and when the disc is completely perpendicular, the flow of the fluid will completely stop.